Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we ran a t-test and the step-by-step procedure using critical values. In this video, we'll run the exact same test, but we'll make the decision using p-values instead. So same logic, same assumptions everywhere, just a different language, because now through the p-values, we're mostly answering the question, how surprising is this result that I have found? The first steps, step 1, state the hypothesis and compute the test statistics. Those will remain exactly the same. And these, as you can see, are the notes that we had in the previous video as well. So in the first step, we are very clearly saying the hypotheses, these hypotheses like define what extreme means, not the data, okay? For step 2, computing the test statistic, again, interpretation reminder for the t-value, it's telling us how far the estimate is from 0. So we're still working with distances as we're talking about step 2 and step 3. It was very important for us to know the distribution because for the t-statistic approach, we had to know the distribution so that we could find the benchmark, the corresponding benchmark. However, now that once that we know the t star, so the value that we compute, it becomes now important for step 4, which turns into find the corresponding p-value, okay? The p-value answers one question, and this is also a bit of a reminder of what we've seen in a previous video for the definition of the p-value. In this context, for the hypothesis testing, the p-value is answering the question that if the null hypothesis were true, how likely is it to observe a statistic at least as extreme as this one? Okay? Keep in mind, when we defined the p-value, so let's say this is our t distribution. For a particular t, like or number that we had or z, the area on the right tail, so the area beyond this observed t statistic, was your p-value, okay? So that area is a probability. And remember, the p-value was that probability. How to compute the p-value? Well, it's either you read the tail areas from a table, or you can do it through a software. Either way, the p-value is a number between 0 and 1, and it's going to measure the surprise under the null, okay? In the video where we talk about how to read the t table as well, we learned that you can find a t value out of a probability or a probability out of the t value. Just make sure that you read the legend properly and make sure you rewatch the video again if you have forgotten how to make use of all of the elements of the t table. Once we have a p value, it's time to make a decision and interpret the result. The interpretation of the result, I'm not going to stop too much on it because it's exactly the same as the t approach. However, the decision rules are slightly different when we talk about the p-value approach. To make this decision, again, we need to know the level of significance. In the previous approach, we needed to know the level of significance so that we could find the t benchmark. In here, we mostly needed to make directly the decision. So again, we're going to use exactly the same kind of notations that we used for the t approach. We're going to write as p star what you estimate. And we're going to call the p-critical whatever level of significance you're given by a particular exercise. And most of the times, this is going to be either a 1%, 5%, or a 10%, okay? So the levels of significance, they will be your p-criticals. Now, what is the decision rule when we use the p-value? If the p star is greater than p-critical, then we fail to reject the null hypothesis. If the p star is smaller than the p-critical, then we reject the null hypothesis. Okay? So in a sense, you can say that small p-values are rare under the null, and large p-values, they are typical under the null. Okay? Interpretation, once again, now that we are comparing the probability to that threshold probability, is not going to change. If you reject, it means that the observed distance will be unlikely if the null will true. If we fail to reject, it means the distance is well within what the randomness can produce. And again, this is about how plausible it is. It's not foolproof, yes, no kind of answer. Now, the p-value approach and the critical value approach will always lead to the same conclusion. And if you are confused about like, well, how can they lead to the same conclusion if their rejection rules are the different? Well, that is because of the inverse relationship that exists between the t-value and the p-value. The higher the t, the smaller the p. So of course we need to change the sign there for the decision-making process. But otherwise, they should always give you the same conclusion because they are basically two ways of expressing the same idea. How extreme is this result under the null? It's just that the p-value and the t does it through either distance versus probability or cutoff versus an area. Okay. So with this video, we've covered the p-value approach, measuring basically this extremeness directly in probability terms instead of comparing to a certain cutoff. In the next videos, we'll work through full numerical examples so that all of these becomes a lot more clearer to you. So stay tuned and I will see you in the next videos.